see where we're at. Here, collision. Okay, collision is working though. Alright, let's look at the to-dos. Okay, so that is not clear. All locations have a transparent border, probably fine. Yeah, probably fine. Yeah, so that is probably what I need to be working on now. Should the world space be bottom up? Yeah. Yeah, well, yeah, we'll see. Well, actually, we might see, like right now, have the answer to that. Store in assets per entity. Oh yeah, that is interesting. Alt tab, yeah, whatever. Grounding, yeah, we're not doing that. But for now, I guess that's not relevant. Oh yeah, collision and mirroring. I need to work that out. Do that when grounded, we're not handling grounding. Special glyphs, yeah, like we don't need that right now. That's temp string, this is drawing collision lines. Yeah, that's probably fine. This is drawing collision shape, that'll do. Flip line, I think that is actually the thing that's supposed to fix mirroring problems. So mirroring, okay, well let's pass it into the shader. This flip line thing. So that would be per instance, presumably. Will it? Well, I mean, it's actually per sprite, but as far as the GPU goes, I guess it's gonna be per instance. So in addition to offset, there's also gonna be float. Well, I mean, I guess we can make it a float too. Flip point, flip lines, flip lines, and yeah, flip line X would be flip lines X, flip lines, yeah, probably just lowercase. Flip lines X plus input, and this is input dot flip lines X. And yeah, alright, so that would be doing this to do. Now we just need to right, rect, screen rect, sprite. Okay, so atlas location is these two things. Top left mirror, then it's atlas location. There's also offset. Oh yeah, atlas location actually has that. Yeah, it has all three of those. And then flip lines. Well, yeah, that is an entity thing. So again, I don't think we have a per entity storage right now, like at all. Yeah, so what we are allocating storage for is sprites and screen rectangles. Yeah, we're not storing anything per entity anywhere. So might as well create that storage then and put that into the sprite tract, like here. It's not Yeah, it's not to do with the atlas location because the flip line is gonna be the same for entities. Anyway, so this is gonna be what, v2 flip lines, because we need to pass that in. Yeah, we do need to pass that in. Okay, where is this mentioned? Here. Okay, offset, so we're adding flip lines. Yep. Sprite rect flip lines. For instance, yes. Yeah. Okay, that works for me. Yeah, that works. Now, rect's sprite. So they are being copied here. Map on map. Sprite rect. Yeah, so this is where we're setting everything. Okay. Sprite rect flip lines is, I mean, this would be pulled from the same place we're pulling this stuff from. Flip lines, let's say 3 0, something like that. Yeah, because some sprites will have a Y, so might as well just give a Y to all of them. Flip lines is flip lines. And just set it to the same thing. Is this gonna... Okay, that seems to be passing through fine. No errors. Alright, so now we have 3 things to store per entity somewhere. And all of these are known, like, well, they should be in assets, pretty much. I suppose I should commit this for now. Let's see, generated change, interesting. Changed here. I recompiled shaders today and they're different size than they were like last time. Okay. Did the graphics driver update or something? Like, why would that be the case? Well, it's the same shader compiler. Why would it? Oh wait, I changed the shader. That's right. I changed the shader. Yeah. Okay, that makes sense. Yeah, that's fine. All right. Sprite HLSL. Yeah. Okay, pass in flip lines. Okay, so these 3 things need to be in assets. So what's in assets right now? There's the font information, which is apparently 1 number. Yeah, so there's font information. There is atlas information. And then there is animations. So that'll be per animation, right? So this is per animation. This is just shaders. So yeah, we need 1 more of those. So atlas locations, that's per sprite. Yeah, so we need 1 more of those. Arrays. This time per entity. So there is our entities, 2. imagine we should need to put that in there somehow. Okay. Might as well do it at the end, I suppose. Yeah, well, the end would be here, after shaders. I mean, should it be after shaders? I mean, I guess it doesn't really matter where it is exactly. It could also be the first thing we store after. Yeah, it doesn't really matter. Asset, begin. Actually, what do I want to be in there? I guess what I want is an array of per-entity information. And we kind of know what that is. It's collision offset, collision dimension, so a rectangle. And it's just flip lines. Asset begin struct. Asset end struct. Well, actually begin struct and struct. They could be parallel arrays, just rectangles for the collision shapes. Yeah, I mean, we could make that. Asset add array field. And the field would be rectangles, right? Rect and rect collision shapes. Collision. Well, I suppose that would. Okay, like we can namespace it. So this is entities. Okay, so asset add array field, rect collision. Well, collision rectangles. What is this? Data and how much of it there is. Data. Yeah, so that needs to come from somewhere. And I suppose for now we're just going to have to fake it. Rect temp collision is yeah, temp collision is just two rectangles. Just two rectangles. Here we go. So this is a rectangle, right? So this will be offset minus 2 minus 3, and dimensions, which is 3, 6, and something here, empty. I guess empty rectangle works. Okay, so now this data is in here, and the amount is just array count. Is that. Okay, let's see. Rect collision, yeah, temp collision, size of temp collision, size of the collision. Is that size in. No, that's just the size in yeah. Let's see. Element count. Yeah, this is element count. That's what I'm passing in. Let's see what that generates. That generates that. Two rectangles. Yeah, that's what we want. Entities like. Okay. So does that mean we can just read that in now? Like we don't need this. So we should be able to look up collision offset. Well, correct collision is assets. What did I call it? Asset data? No? No, this is something like that. What? Why isn't? Ah, it's in the game. Yeah. Game assets entities collision and then sprite common no sprite entity. There we go. So that should okay. Top left. So that's the offset. Collision dim is, well, I mean, that is just collision dim, isn't it? Collision dim. And this is, again, collision top left. And, yep, okay. Collision top left, collision dim. Yeah, I mean, yeah, we could just look it up here as well. Because we have the sprite here, right? Yeah, we do. Okay. Well, that's what we had before. That's fine. So now, now it's just the flip lines that also need to be stored per entity. And I mean, we could just do that. Just have v2 flip lines. Temp flip lines. So that would be v2 temp flip lines. I do. Oh. Alright, temp flip lines. Yeah. And then what did I just say? 3-0 for that. Okay, so that's an array of collision rectangles, that's an array of flip lines. That works, so we should be able to remove this then. And wherever it's relevant here, and this would be game, assets, entities, flip lines, sprite, entity. Okay, so there we go. Yeah, now we just kind of need to not have the temp stuff here, so just pull that out from somewhere, and then we're good. Well, let's start with the collision shape. So the collision shape is not the sprite shape, because it doesn't make sense to collide with the whole entire sprite all of the time. So that needs to be encoded somewhere in the art, presumably in the idle. Because like the sprite doesn't, I mean, unless we want the sprite to change per animation or something. I mean, the collision shape to change per animation, which was probably not what we want. So if I just define the collision shape here, that should be fine. Now, well, I mean, I've specified the collision shape to be a rectangle. So, and not like a set of rectangles. I mean, does it make sense for it to just be this rectangle? You just collide with this whole rectangle except for the arm, like the arm can pass through things. I mean, unless of course we want it to be this whole rectangle, but then you'll be able to like stand on things with just hovering over them, like that doesn't make sense. Yeah, so it's probably this rectangle, so okay, well, yeah, what's the new layer again? Layer, new layer, shift handle. Alright, layer. I mean, I could just call it collision. Mode. Normal. I mean, why not? What's this user data thing? Oh, you can just add user data? Like what? Which is a string. I see. Well, yeah, I mean, why not? Can I pick a color for? I mean, I guess let's make it like magenta. Nobody ever uses that for anything. And I'll just draw it. Head. Yeah, probably. But then again, like we don't. If it's just a rectangle, we don't really need to draw the whole entire rectangle, right? Like we could just draw like 2 points, and that defines the whole rectangle, and that should be enough. Yeah, well, let's do that. So now I need to read that layer. Somehow. Actually, what's gonna happen if I try to build this? Is it gonna, yeah, it's gonna, assertion error, somewhere. Here. Yeah. Because I tried to push that texture and I don't have room for it. And why is that? Because total Atlas texture count is just however many animations we managed to find. Yeah. Okay, well, at least we have some kind of a check for this, so that's something. So this could go away pretty simply, right? We could just say, well, this is what happens. Actually, why is it so indented? Isn't that what it's supposed to be? Oh, wait, this whole case is not. Hold on, this is what it's supposed to be. This is what happens when it's not a collision shape. If the layer name has collision in it, then that's not what we do. And I think the layer name has collision, like somewhere. So we're ace type chunk cell well, cell has these things in it. There we go, layer. So layer tells us what the layer characteristics are. Chunk layer. And so we don't really care about any of these things. Where's the name? So let's see, hold on. So this is the file. The file contains frames. Okay, so for each frame there's multiple layers though. So we don't have layers here directly, but we do have chunks. And one of those chunk types is layer. Flags type, child level, default blend. Oh, it is. It does have a name. It does have a name. Okay. Okay, chunk, layer, name. That's a real thing that's really there. Yeah. Okay, str name is what? We need the pointer. The autocomplete is not quite working for ace chunk type. Layer flag, layer, yeah, ace chunk layer. So it is a string which is a length name str and chunk layer name length there. So that's what the name is. Write to stdout name and then write a new line. Okay, layer 1, collision, layer 1, layer 1. Okay, so it is correct. Okay. Bool last layer chunk is collision. False. Is strack name collision. Okay, so we can set that, and then if we see a cell, if last layer chunk is collision, then we do something, otherwise we just treat it as a texture. Yeah, something like this needs to happen. Now, okay, where are we failing now? Huh. It seems like we didn't treat all the textures or something. Interesting. Okay, well, we'll see. Oops. That's not the right thing. Okay, so last layer chunk is collision is add to watch. So true. True. What's the name? Layer 1. Okay, well, obviously it's not that. Okay, well, they aren't the same length even. So that's false. Yeah. Okay, now name is collision. Okay, so step in. They are the same. Result is true. Okay, last layer chunk is collision. Okay. So we enter in here. Yep, it's not. Yeah, right. Then we are here again. Even though it's a different texture. Wait, do the layers come in like the same order as the cells? So like the first cell was layer 1 and the second cell is collision? Like, is that what happened? I think that's what happened. So, oh my god. Okay, that is not, does not make it. So the layer description does not come before the cell, seemingly. It's like all the layers and then it's all the cells. We can kind of see it. It's layer, layer, cell, cell, seemingly. Okay, so this needs to change then. We need another array. To hold our stuff. So like layer info storage. And like one of these. Bool. I mean, right now layer info storage is only storing a bool, which is that. Is it collision? Layer of layer is collision. Arena alloc array arena bool. And how many of those are we allocating? I mean, it doesn't really matter that many, why not? Layer is collision is well, this is gonna be a struct actually. Bool pointer, and then i32 length capacity. Pointer capacity Alright. Okay, there you go, layers, collision. We now have an array of those things. So you can... So for each frame, yeah, it seems like we're receiving layer information for each frame. Unless we are not, or is it per... No, layer is per layer, right? So it should be... It should be per file. It should be just one set of layers, presumably. It's not like they can be different per frame. Because if a layer has a name, it has a name, that same name for every frame. Layers collision, length is 0, so just reset it. And then, so that's for each file. Yeah, so for each file reset it. And then whenever we see a layer chunk, just pull the name out. That's not going to be the case anymore. There's a bool is collision is that, and then our push layer is collision. And is collision. And then we need to somehow keep track of what layer we are in. So now we have this layer information. Actually, what else is in the layer? Come to think of it. It's probably relevant. Well, child level. Yeah, so child. So instead of yeah, we don't really know what order they come in, right? Necessarily. So they have the child level in them, though. And I believe the child level we can use that. So instead of it being this length capacity situation, let's just have a length, and then we're not going to be doing another push. We're just going to set. So layer is collision pointer chunk layer child level is collision, which is that. Yeah, and what does the cell have? Does the cell have anything to do with that? Index, position, opacity type, z index, width, height, compression, okay. A sprite file format, let's see, like do they come in the same order? Am I supposed to reconstruct the order or what? Where is the first specs? There we go. Cell color layer chunk. In the first frame should be a set of layer chunks to determine the entire layer's layout. Yeah, and this has child level in it somewhere. Yeah, see note 1. Yeah. The child level is used to show the relationship of this layer with the last one read. For example, 0, 1, 0, layer name and hierarchy. Foreground. The layer index, okay, so that's node 2. Cell chunk, so layer index is node 2, okay, so they are related, okay, seemingly. The layer index is a number to identify a layer in the sprite. Layers are numbered in the same order as layer chunks appear in the file. Ah, I see. So we don't... So the order that they appear in the file actually does matter. It's not just arbitrary. It means in the file you will find the background layer chunk first, then the layer 1 chunk, and so on. Okay. As layer chunks appear in the file. Okay. Okay, so it is a length capacity situation then. Let's just change that back. Opacity. And let's reset the length here, yes. And then we're not going to be setting it. We are actually going to do an rpush. Rpush layer is collision is collision. Alright, so push that in. Last layer chunk is collision. Yeah, so at this point we kind of need to know bool is collision is that index, is the index into the array. Is, should I have an rget that just does the check for me? Probably. Rget layer is collision and we want to get chunk cell index. That's what we want to get. Yeah, that common. So we have an r push. Might as well have an r get. Define r get array index. All right. Well, it's array dot pointer index. You know, kind of. Except that, you know, it's not quiet. It's like this will work, but it doesn't have a check. Yeah, okay, how do we introduce a check in here? I guess you can do index is less than array length, question mark, index, otherwise like 0, but we want like a debug break in here. Is that correct C? Yes. And I suppose it's not really a debug break. It's more so just an assert. Except that I don't think we can just put that whole assert in there. So it kind of has to be like one of these debug breaks. Yeah. Well, assert action, I suppose, is what that is. Let's move the assert up. Yeah, let's leave it there, I suppose. Oops, I forgot to, alright, if is collision is that, and then if is collision, then we go in here. And do something, otherwise we don't. Right. Okay, so we're still failing here. Alright, interesting. Well, let's see what we get. Okay, so we get one layer, which is layer 1. File info. This is commando idle we're reading. That file. Yeah. So is collision, we push false, then we push true. Wait, hold on. No, this is 0 index, yeah, this is fine. Okay, then we push that second one. Apparently third one. How many layers did we... What? No, length 2. Oh yeah, we just stuck there. Okay, length 2. And it's like true, false, or whatever. Okay, so what's this? 0. Well, the 0th index is collision. This collision. Like it's the same order that they appear in the file, it says. Well, actually, I think it's backwards to how this is drawn here, because this is on top, but like this appears first, as in it's like most background. Okay, so is collision, the first one is false, so we go in here. Is collision, that second one is also false, even though cell index 1 add to watch well Is something wrong with the macro? If the index is less than the length, it would have failed here if there was something. If the index is less than the length, then it's the index. Otherwise it's 0. Okay. Okay, index is 0, is collision is false. Index is 1, is collision is false. Index is, what's the length? It's 2. Okay. Index less than the length. Index. Index is less than the length. Okay, no. That's not like working as expected, but I suppose I could just literally pull this out and see what that evaluates to. Temp, oops. Temp, well, yeah. At the end of declaration. What is it talking about? Initializing I32 with an expression of waffle type void. Really? So there is something wrong with the mug. You can't just put a debug break in here. Oh, can you? Wait, you can't? What is this? Okay, so that just doesn't evaluate to anything. So how does the macro even compile? Like, which element is being pulled out? Like, what? I mean, kind of, I guess, know that it's not the right element that's being pulled out. Actually, can I do the assert? Well, I mean, that's what I do here, but now I can't actually do the assert very easily. Yeah, that is the problem. Interesting. False when the index is 0. Also false, even though the index is 1. Yeah, see, that works. False, true. What on earth does it do? Like, it compiles, so it's like, it's correct code, but this is a void expression, apparently. Somehow. Like, somehow this is a void expression. I mean, it would be nice to have a bounce check there. But I guess if we can't have it, then we can't have it. So if it's collision, then we need to do something. Specifically, what we need to do is go through the layer and figure out what the rectangle is, and then store it. And then store it. So I came to think of it, we kind of want all of this, right? Well, not Atlas location. No, we can't, well... Yeah, so we have this offset, So the offset should be relative to that first frame. That first frame art offset. But to figure out what that is, we need to actually read that cell. And I mean, ideally this wouldn't really... I mean, we could just store what the offset is. Actually, is it gonna be the same? Oh. Oh, that's interesting. So... So it's gonna be the same no matter where this is, right? So like you make it... Oh wait, no it isn't. Or is it? Oh no, it's different. Yeah, so this is different depending on what's in the layer. But we specifically want this offset to be relative not to its layer, but like to the art. But that could be fixed up later. So at the moment we can just store offset as is, and then figure it out later. Layers, collision. So what we want to store is rectangles, right? So it's like well, we want to store multiple things. Let's struct rect star pointer i32 length collision rect length is just however many entities we have. File infos entities. Oh yeah, that's the animations and stuff. So entity names deduplicated is actually something that we need access to. Right here. Length. Right. And then collision rects pointer is arena. Alloc array. Arena. Collision rects length. allocate the rectangles. So we now have the rectangles. We need to know what. Okay, so if this is a collision shape, then we kind of need to know what entity we are looking at. So we need to search the array, I suppose. And let's just file info entity. Well, actually we don't. File infos entities. Like we're inside, yeah, info. Info names entity. Yeah, so we just have that right here. We'll have the name. But we know it's gonna be well, actually, we know they're gonna be in the same order as they are in that enum, so we don't need to like search the array or anything really. We could just figure out what the collision is here. Rect collision is, you know, we figure it out. Let's say it ends up being this. And then we do an rpush to layer is collision. Of course, this kind of assumes that every entity has a collision shape. Which I suppose they should. No, not layers collision, this would be actual collision rectangles, collision rects. Okay, collision rects, collision. Okay, what's this? No member name capacity. Yeah, I should really have that. No. So we're gonna be pushing them in every time we see a collision, and there should be one per entity. At least that's how it's working right now. So like here we can assert that collision rects length equals collision rects capacity, which should trigger. Yeah, it does. Because we don't have collision in Blue Marine, so we can just define that real quick. In the open file, again, idle shape could be. So, do we have a magenta in here? Can we like add? Oh my god, what is that? Oh, I see. Yeah, so let's just say RGB that is gonna, can you save it in the no? I wanna oh, fuck. Like, let me just modify the color, like clearly allow me to do. Just modify this fucking color. No, not. Okay, so if you just change this, that doesn't modify it, which kind of makes sense. But like, how do I modify it though? Right, modify color in palette. Sure. No, no, that's not what. How to add new colors to your color palette? Yeah. Ah, so there is a button. Okay. What's this? Add to foreground. Add foreground color to palette. Well. Oh, it adds a. God. So what's the point of this then? Why does this exist? Like fuck's sake. No, wait, hold on. I'm the opposite of that. Oh my god, the UI is just so good. Okay, there it is. There's magenta. Okay, let's save that. I need a new layer. Collision. And let me just mark the collision. Save. Okay. So there's the collision. Yeah, we don't need that. Yeah, alright, let's see, so if we run it, so now it compiles, and this presumably won't actually affect anything, because I'm not using the information. But right now we're pulling out collision rects. They are not correct collision rects. We are pulling them out, at least. So now with this temp collision, so that needs to be collision rects pointer, and this is collision rects length. Pull from part. Okay, so that's that. So now it's being pulled out from here. Okay, pull out from texture. So presumably this this part is still the same. For all of them. So this part is the same. But if it's a collision, then let's just do this, where we go through 4, 4. Okay, so for what? I32 row. Well, actually, it's not even that. We don't even need this, because like these offsets already tell us everything we want to know. We don't even need to scan the texture. never mind. Let's just put that back in here. So this is just what? Chunk cell. Well, position X, position Y as like for now, that's, I don't think that's correct. Position X, position Y. And width and height. Okay, so that's not gonna be like super accurate. So yeah, so it's like off somewhere because I'm not accounting for that art offset that needs to be accounted for. How do we account for that? Well, first frame art offset needs to be used. Okay, so as soon as we, well, not as soon as we set it, but probably after we are done iterating through the chunks, which is gonna be here, just before we move on to the next frame. Yeah, so like right here, before we move on to the next frame, if this is the first frame, that means we have obtained all of the information. Well, have we though? So specifically when we found collision rectangles, like if found collision, then assert frame index is 0. Because it doesn't make sense to find collision anywhere else. Bool found collision. Yeah, found collision is set to false for every frame, and then we go through the chunks of that frame, and if any of them is a collision chunk, then we say found collision. And that also corresponds to us pushing in the collision rect. So if we found a collision rectangle, then assert frame index is 0. And specifically what we want is that, yeah, we want to access that first frame art offset. Yes, so first frame art offset. So whatever offset we have, we need to take the first frame art offset and subtract that. Or, so like this is 20, and well, in this case it's going to be the same for this layer as well, right? 20. But if collision was like here, then you would take 20, you need to move up, right? Which means that what? If the offset for the art is 20 and for us it's 15, then we need to move up by 5. So it's first frame art offset minus our offset. And same here, if this is 20 and this is 10, this is 20 minus 10, that's 10. You move to the left by... yeah, well, y is up versus y is down. Okay, well, you might have to flip the y there. Let's see. So, if we found collision, that means the last collision rectangle, rect is last collision, rect is collision rects pointer plus collision rects length minus 1. Assert length is greater than 0. Okay, so there's the last collision rect. Top left x. Okay, so top left x. Let's think about the x one. So if it's 10, but the first art offset is 20, that means it's actually minus 10. So it's 10 minus 20. So minus equals first frame art offset x. So it's that. And y, if y is 10 and the art says 20, then it's actually positive 10. So it's first frame art offset y minus this. Yeah. So it's 10 minus 20 to get minus 10, so to move to the left. But here it's the opposite. Okay, let's see. Well, it backed it. Okay, so that's kind of what we want, almost. It is offset a little bit. In fact, it's offset by 1 pixel seemingly. Nope. Yeah, it seems to be offset precisely by 1 pixel. Okay, let's see. Oops. Build. Okay, so last collision rectangle. 0, 20. Oh, wait. Yep. Okay, last collision rectangle is 1320 and dimensions is 412. 1320 and dimensions is 4. That's this 4 and 12. Yeah, 13 plus 4 would be 7. Yeah. Well, that's correct. First frame art offset is 1320. Okay, so it ends up being 0, 0, isn't it? It just ends up being 0, 0. So we're about to do y is 20 minus 20. Yeah, so it is just 0, 0 then. Okay, well, I mean, if it's 0, 0, then... Oh, is it a transparent border? Yeah, so the collision shape is that, but the texture has a transparent border around it. which is again coming into play here. Because when we say that the sprite is positioned, like the sprite has a top left, like let's see, is that what we are actually colliding with? Yes, seemingly it is. It's exactly that. It is. Okay, so if we just go in and take a look, we say, well, the sprite is located here, but that is actually the transparent border that's around it. So the collision shape. So the collision shape should be offset by 1 more than you'd think it should be, because we're gonna pad out the texture, but we're not necessarily padding out the collision. So we could presumably fix that simply by saying that, well, whatever offset the collision ends up having, just +1 for, well, +1 to move it to the right, move it down. So I guess -1. Yeah, so that is what I drew. Well, I meant to kind of specify in the art. And I guess, I mean, we could make it semi-transparent. So wherever we're drawing the things. That's the update. Collision shape drawing, yeah. So alpha, we could set it to like something. I think we're doing alpha blending just fine, right? So there you go. Yeah, that's probably too much. Yeah. Okay, well, there is our collision shape drawn and specified in the art. And pulled and stored in the assets and pulled out of the assets. Everything we could ever want. And now it's just the flip lines that need to be treated the same. It's like specified in the art somehow. I mean, at this point, found collision. Yeah, not every file is gonna have collision information in it. Some of the files are animations. So it's specifically, so found collision, really that's like, it's like an indicator that we found an idle, we found like the reference animation, no, not the reference, but the animation for that specific entity that has a bunch of metadata that's per entity, such as collision. Yeah, I suppose we can keep it like this. Alright. I suppose this is worth committing, just on its own. That's fine. That's fine. Pull from art. Yep. Just move the assert up. Yeah, these flip lines are not being pushed in yet. No, I mean they are. Yep, okay, that's fine. Let's, I just added some stuff to the idols. But it's all saved, I'm guessing. Yes. Alright, what do we do here? We want to say pull collision rects from art. And the only other thing is the flip line. Which, I mean, that's literally just the 1 pixel. Shift M. Flip lines. Just make it another color, probably. Well, like cyan. Yeah, it doesn't really, just here. I mean, that really depends on, like, what does this mean? Is it like this, or is it that, or is it in between? Yeah, I mean, this might not actually be enough. And, well, unless we also specify, like, oh, we want to flip around. Like, by default, we could just say, oh, it's like the left edge or whatever. So right now it's 3, right? It's like, this would be 1, 2, 3, like here. Is that where we're flipping? 2. Is that what I'm supplying for flip lines? 3. Yeah, so it's 3. Yeah, apparently it is. 1, 2, 3. Flipping around here. I mean, this would have an offset of 13, which is the same as the other one, right? And this would have an offset of 14, so that would be 1. So, oh yeah, so left edge, 1, 2, 3. So yeah, so it's, there we go. It's 3 from here, and it's 16 from like all the way over there. And I guess that is where I'm flipping, just around the leg. I mean, sure. Yeah, if you wanna... I mean, there is a number of ways we can encode a partial one. But I guess by default we can just say that it's whatever that is. 3. In this case, 3 and 3 from the top. Making well. And this would have the same. We have flip lines. And like here or something. Yeah, why not? Just keep it. And so in the build now we need to specify that. Well, I guess this would be layer type or something. I'm gonna go take a toilet break. Just mute. Alright. Let's finish this real quick. So this last frame, was it layers collision? Yeah, layers collision is now not layers collision, it's actually layer type info or something like that. So it's not bool, it's like layer type info, and that is so it's something. Enum, that, and then we've got what? We've got collision. Well, we've got none, not as in not special. We've got collision, and we've got flip lines. this. Yeah, layers collision, so that would be layer type info length 0. Then is collision is, well, is collision is that, but then bool is flip lines would be flip lines that. Now, if is collision, then type push this, else if is flip lines, then push that, and then else push this. So it's not layers collision, it's layer type info. Yeah. Okay, layer type info. Type info. Then layer type info. Layer type info. I guess this layer type info is that. And then, I mean, I guess switch. This layer type info. Okay, so case none, break. Case none is that. Then case layer type info collision is what we just did with collision, which is that. And then case layer type info flip lines is something fill in. That. Yeah. Does that work still? Yeah, well, it works still. So that's something. Okay, well, just the flip lines need to be filled in. Otherwise, we're good. Okay, well. So, lines, I suppose it's really just the, it's really just that. It's just the position, for now, at least. Push, and we have to fix that up. Okay, so bool found flip lines true. So flip lines are those, then our push flip line points or something, and flip line positions. Positions, flip lines. Okay, now we just need to allocate that. So this is collision rex, this is flip line positions, flip line positions, and it's not a rect, it's a v2. Yep. If found collision, if found flip line, found collision, found flip lines, if found flip lines, then I guess assert both of those things. Flip line positions length is greater than 0. Then what? Oh, it's 3. Oh yeah, right. Well, it's a similar kind of manipulation. I mean, I suppose at this point we kind of need a static v2 fix for first frame, adjust point to, oh god, adjust ref point, if adjust ref point, yeah, that'll do. v2 ref point, and then v2 first frame art offset. That, and the procedure is just these two things, really. Ref point, except that this is like, alright, so this is v2 result is that, there we go, return result, yeah, first frame art offset. Okay, so last collision rect, top left is adjust ref point by first frame art offset. And here it's kind of the same, right? It's v2 v2 star last flip line is flip line positions pointer pointer plus flip line positions length -1. Okay, so that's the last flip line, and then we just write to it. Adjust ref point, last flip line, first frame art offset. Yeah. So now we actually need to use this. That would be flip lines, collision, flip line positions. Okay, that compiles, that's good. So flip line positions, now we need to write them out. So that's not gonna, okay, so this is just that, but instead of collision rects, it's flip line positions. Okay, so now it should be a little different, yeah, so because of that +1. So this should actually be, what's pencil B? Yeah, just here. Yeah, so there we go. Well, we do know that we are actually pulling the stuff from the art. So that's good. Although it's almost like, I mean, isn't that just halfway through the collision shape? Like, is that always going to be the case? Because if so, then we could just do that instead. We can just say the flip line is always going to be halfway through the collision shape. And then just work it out that way, and flip it. But yeah, for now, I guess I'll add a to-do around flip lines. Should flip lines just be halfway through the collision shape? Alright. What do we got? Yeah, we're just pulling out collision shapes and flip lines. Have that to do, modified art. There we go, pull flip lines from art. While I'm here, maybe I should figure out. Maybe I should figure out how Twitch works. Let's see. Okay. All right. Interesting. So do I have a dashboard? I never tried to find it. Presumably I have it somewhere. Yeah, well, okay, I can do this. Yeah, that's great. What else can I do? Can I? Well, alright, I have settings. I have settings. Yeah. Well, it's good to have settings. Community, okay. Prime, notifications, bits. Modes, creator dashboard. Okay, that sounds promising. Your manage stream manager. Okay, there are all sorts of things in the stream manager. Activity feed, bitrate, session time, edit, manage. Okay. Okay, so it's the stream manager. That's like the dashboard. Okay. And that has a chat as well. Suppose I could just have it up instead of, well, although can I? Yeah, maybe not. Maybe not so much. Alright, well. Rate channel. Oh boy. Channels you have to type it in. I mean, that is just an amazing bit of interface design. You have to type in the name. I mean, okay, that's one way of doing it. home. Anyway, that's different though, and that is just they don't make it. Okay, that is one weird way to organize a streaming dashboard. Okay, let's see. All right, random. Okay, working on it. Alright. Interesting. Well, anyway, I think that's enough of that. It's gonna be all for today. Thanks everyone.